Is that okay, sir? Hello?
Yes, it is fine. Thank you, Vijay.
Okay. In the phase one, we had carried the NLBC. It is showing, has been already shown. In that screen, it was not showing, that's why. In the phase two, we had carried this one. Yes, super. Yes, it's very.
Being the 13th most water-stressed country in the world, with projected increases in population growth, coupled with increased.
Hello. मेरा मत करिए थी. It is not working. Hello. Sir, is that video, is that presentation is, hello?
No, Vinodji, now we can see your screen. Yeah, now it is visible. Vinodji, is audio there with this video, or it is just a video without audio?
Pardon, sir?
Can you hear some audio also along with this video, or it is just a video, just for like...
No, 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 no. After that, we will explain.
Okay, okay.
Okay. I hope you enjoyed the video. Uh, Okay. Now, the scope of the SCADA Phase 2 is automating about 3,000 kilometers of canals and the installation of 4,203 of automated gates, automating 144 existing manual gate structures, 45 new automated cross regulators for better water level control on the primary canals, 60 microclimate weather stations, which are the major importance for the decision support system, and 15 wireless radio towers, which each the whatever the inputs we give from the SCADA center to communicate the major things, 15 wireless radio towers has been installed on sophisticated and secure software. Okay. This is the wide reputed vendors they had used and everything. This is the scope of the work of the phase 2. Okay. Next, the control and measurement system, what we adopted. Control and measurement system, what we adopted. That are these gates are very different from the conventional gate system. Okay. One thing is the flume gate, slip meter, slip gate, flume meter, and picometer. Flume gate is adopted in the chuck structures, mainly in the cross regulators. Slip meters are adopted in the offtake of the distributaries. The slip gate is adopted for the escape gates, and picometers are adopted in the DPOs, okay, outlets, okay. How the flume gate is the working principle of the flume gate, I want to explain the main thing of the hydraulics, okay. The flume gate, okay. The flume gates, the main feature of the flume gate, it is measure the water level of the upstream and downstream with ultrasonic water level sensors, and it is a solar charged system. This is a mainly overshot design. The water flows over the gate. It is work as a rectangular gear. Why we had provided the flume gate as mainly for the check structures and for the cross regulators. The rectangular gear is more sensible to the levels. With only less level changes, we will get the discharge variations. That's why it is very proportional to the H raised to 1.5. But the orifices, the undershot gates are sensible to water levels, very less sensible to water levels. If the water level is also changes, there is a very less variation happens in the discharge. Okay, these are the gates which are suitable for the cross regulators. Okay, next is the how we had adopted the flume gate for the existing structures. How the picture shows the existing structures. Next thing, then we had constructed the new cross regulators. About 43 new cross regulators we had installed. It improvises the operational control. This is the slip meter. The slip meter technology it is also used the mainly technology of the ultrasonic only. Okay. Level sensors are easily removed during in-field servicing. Servicing can be done by local Rubicon field technicians. These are the undershot gates which are working as the orifices. Orifices are better for flow rate control than gears. Okay. The mainly technology, the fume gates are used. The transducers are adopted either of the in the picture you can see in the elevation. Is that my cursor and everything is visible?
Yes, it
Hello?
is visible. It is visible.
Yes. Yes. These are provided in 8 layers. Okay. In 8 layers, in the plan you can see in the either of the side we had provided the 8 plus 8, 16 total 32 transducers are provided, 16 one side and 16 other side. These are used to communicate for measuring the velocity, even in the straight line, even in the diagonal. Why we have to provide the diagonal? Even the flow is non-uniform also, and if any eddies also, we have to get the resultant velocity, which is very important for the ultimate discharge. Okay, you can see the result. You can see the how it is the working principle. Okay. And the next is that slip meter. These are the existing gates which are offtake of the distributor is provided. Next, during civil installation, we have provided this one after off. Okay. Slip meter. We get on MBC distributor 25 and 26. Next, the picometer. The picometers are provided mainly in the outlets of the canal, which after the outlet it will go to the field irrigation channels. Okay. This is also orifice technology. A flow measurement accuracy of plus or minus 2.5%. High quality component designed for long life. Control and meter compensates. Easily accessible for visual inspection. Undershot gauge work as a orifice. In the picometer technology, total 20 transducers are provided across all the planes of that circular section. 5 planes, total 5 planes. Even this is also work in the straight lines and diagonals. Even in the top of the orifice also, on the top side of the orifice also, transducer used to provide that even measures the how much water is flowing inside the picometer in the circular section. The picometer also has a downward facing transducer to determine whether or not the measurement cylinder is full. This is a picometer. These are the picometer pictures which are installed in the different outlets of the MBC, SBC, canals. Okay. Even we had refurbished the existing head regulators. We have not changed. We are providing the actuators and by giving the sensors, we had refurbished the mechanical gates. Existing cross regulator, electrical refurbishment has been carried out. Okay, actuators. We had provided the actuators. These are the actuators which will work with the sensors, and it will give by the local RTU. It will send the message to the main SCADA system, and the canal system also can. The head regulators can operate. These are the flow meters in the chuck structures. In the main canals, we had provided the. Hello? Sir, please. मेरा आवाज नहीं सुना दिया. Okay. One second. I will try. Okay. जोर से बताऊं. Okay. Okay. Oh, okay, sir. I'll check. Am I audible, sir?
Yeah, actually issue was with my system. It's audible. Please continue.
That my screen is visible? Is that my screen is sharing?
Yes, we can see the presentation.
Okay. Can I continue from the slide 17, sir?
Yeah, please.
Okay, this is the fume rate. The main feature of the technology of the fume gate is it is operated by the ultrasonic water level measurement, which is measured upstream and downstream. Okay. It is a solar charger system. This is designed as a overshot design for better water level control. Mainly it works as a rectangular weir, movable weir, which is very sensible to the discharge of the weir, very sensible to the water levels. With only minor changes of the water level also we can reach our required desired design discharge. Okay, suitable for the mainly for the cross regulators, which is work as a chuck structures. Okay, fume gauge type of cross regulator on JBC 44.3. These are sir, am I audible? Hello, hello, hello. Sir, am I audible?
Yes, sir. Yes, sir.
Okay. This is for the existing structures also we have fixed the fume gates, which you can see. Next thing that we had constructed the new fume gate chuck structure. Around 43 new chuck structures we had constructed, which is very important for the water level. Okay. This is a slip meter. I hope have you have the slip the features of the slip meter is the accuracy. It works with the plus or minus 2.5%. Level sensors are easily removed during a field servicing. Service can be done by local Rubicon field technicians or authorized trained independent local integrators. Okay. Okay. It is an undershot gate which is work as orifice, which is less sensible for the water levels. If the water level decrease also, we can reach the desired discharge. Okay. The ultrasonic array principle maps the velocity profile by using multiple transiting paths. This is fixed. The total 32 transviews are provided. Either of one side is 16, one side is 16. They can interact in the straight lines also in diagonals, which is very good for the technique measures across the entire velocity field within the meter box and is resistant to swirl or other non-uniform velocity distribution caused by garbage or other debris. It also elevates the field for flow profile calibration that are required for single point, single path and velocity sample based metering technologies. You can see here the whole technology. This is the picometer.
Mic off कर दीजिए. All participants are requested to switch off their mics. Please continue, Vinodji.
Even we had refurbished the existing gates also by providing the actuators. These are the actuators. You can see the actuators which are connected to the operation of the gates. Okay. These are even the flow meters also provided on strategically wherever we need. 33 flow meters has been installed in the entire commanded area at a strategic location that will be used for the measurement of the flow and the head of the water in the channel. Okay. The main important captive radio communication network. We had used the IoT, LoRaWAN technology and MDLC, Mission Critical Channel Control, shared 900 MHz spectrum with a managed performance through Motorola integrated platform, high reliability ensured through dual redundancy and protection against network outages, end-to-end security for IoT infrastructure, edge computing capability. If we not get the redundant communication also, we can handle the gate operation on the local also. Edge computing, that is the edge computing capability, enabling on-farm control through IoT. Flexible integration for LoRaWAN with MDLC network, cloud-based applications. LoRaWAN technology for district level or third-party use. This is a non-licensed technology, which is it needs a very less data to communicate from each gate to gate. Okay. You can picturization here. Each device has an RTU and radio, unlicensed. Okay. The multiple device will be connected to the one radio node, and each radio node also can communicate, and each from gate to other node, from that node to another gate. That is, we can communicate like that. Multiple devices are connected to each radio node using point-to-point, multi-point communication scheme. Peer-to-peer communication is also possible between devices, which is used with our network control solution. Each node has a radio plus RTU for point to multiple point and radio for point to point. Backhaul commonly 5.8 GHz unlicensed. BAT. Two-way communication is backhauled to the operator center from the node to node using point-to-point communication scheme. The radio and gateway connect the system to a server and sources. Okay, these are the gates how we had provided strategically wherever we need across the commanded area. Okay, even we had installed the strategically the weather station also. The mainly weather station is very important to make the decision support system. Accurate, reliable measurement of rainfall, temperature, humidity, and wind speed direction, solar radiation, and atmospheric pressure. Innovative patented rainfall measurement system that is high precision of plus or minus 0.05 mm, high intensity up to 2000 mm per hour. Even that also we can measure. Low maintenance with a unique flush valve mechanism, avoiding the buildup of debris associated with the traditional rainfall methods. Okay, tipping bucket. Dual sensor for redundancy against the long-term drift. Integrated pyranometer, solar radiation also we can measure. Ultimately, we can measure the evapotranspiration. Okay, all new precipitation collect. This is a pyranometer, also sensor. You can visualize in the picture. These are the 60 weather station has been distributed over the commanded area. We had provided the marine grade aluminum, which is high strength gauge leaf construction using techniques adopted from aerospace and marine industries. Laminated panel assembly results in strong, lightweight, and corrosion resistant gauge leaf suitable for canal environments. These are properly tested and everything. And chemical testing was conducted. For calibration of the provided gates, we have mobile flow testing lab. Flow lab development is completed and final testing has progressed at site. Flow meters are used in flow lab are tested at FCRS. Okay. This is a very important after the installation of the gates to calibrate the discharge. Even the mobile lab is also we had established to calibrate the existing gate discharges. How we made the hydraulic modeling before the installation. The input data used to develop hydraulic model included cutoff statement of the Mudbal, the example the Mudbal branch canal. Cutoff statement of the Mudbal branch canal has been carried. For modeling purpose, the starting and the ending canal bed level has been used. This incorporates any sudden canal drops within the canal. The canal drops appear to be relatively small and is not expected to alter the result of the modeling. These are the outlets offtake of the distributors. You can see the red points, these are the offtake of the distributors which are within the pool, water pool. These are the test structures. These are cross regulators. You can see the pool. Within the pool, that are the offtake of the distributors. Design flow of canal. This is assumed to be satellite imagery to verify the distributor offtake size. Operation and maintenance. This is the interface at the SCADA system. The first one, mobile screen for the quick access, and which shows the gate health in the SCADA center. Gate health status as seen from the SCADA center. We can see the capacity of the battery and the ability of the solar, everything from the SCADA center. Okay, the gate positions you can see here. The mapping of water management. Each hierarchy basis we had mapped the operation of the gates. Superintendent engineer can operate the head regulators, escapes. Executive engineer can only operate the offtake of the distributors. Assistant executive can operate only laterals and sublaterals. The concerned AE can operate only DPUs. The post-implementation scenario of SCADA. SCADA project is successfully implemented on entire NLBC network for command area of 4 lakh hectares. The benefits achieved are real-time monitoring and control increased water use efficiency in the network, resulting in water savings and increased irrigated area, reduction in water loss and increased crop productivity in tailend. Online water demand, water billing, revenue generation, better service to the users. Water delivered to the suffering cut area of tail end users of about 1 lakh hectares. Huh? This is the data which shows the improvisation of the suffering cut. About we had improved our suffering cut 1 lakh hectares. Restored suffering cut restored after ERM and SCADA about 1 lakh hectares. See, this is the how the manual gates can't maintain the water level at the chuck structures. It shows the animation you can see here. The variation of the water level at the chuck structure will result the improper supply of the water at the DPOs and the offtake of the diffuse. See in the how the flume gates can maintain the water levels at the main canals. Okay. See, this is one of the data we had carried the without automated the gates, okay, of the MBC. See, the variation of the deviation, which shows the deviation of the water level at the main canals, and of course it will result the improper distribution of the water at the outlets. This is the simulation. Simulation recorded on MBC canal during non-autonomous operation. The graph illustrates the fluctuations observed when the last two water pools are maintained at the low levels and canal automation is implemented. Correspondingly, the water level deviations and flow rates vary to ensure water delivery to the designated location. Okay, after the automated, see the deviation is very reduced here. You can see the deviation water levels within the plus or minus 0.1 meter. Okay, even the calculated flow is also maintained. This is one of the studies. The SCADA trend shows a steep rise in water level which alters the operators to intervene take corrective actions thus preventing any mishap from canal overtopping. The water level when the water level is increased over the lag and in more than the FSC full supply depth, immediately it gives the alarm to the operator and it prevents any mishap from canal overtopping and thus maintaining canal safety. Higher level of service for providing consistent flow to the farmers. Through enabling automatic flow control, the automatic gate has been consistently providing the consistent flow rate through the gate. In this mode, the gate automatically adjusts its opening to ensure that the constant flow rate as stipulated by the engineer or farmer is maintained irrespective of the water level fluctuations in its vicinity. This consistent flow rate ensures that the water application of efficiency on farm is high. Okay, in the high 80% compared to the traditional flood irrigation. How the tail end before, during and after, how much it is improved about the 90% overall tail end and serviceability has been improved. Okay, you can see the data before how much only it is about only 30%. Now it has been improved about 90%. This the data shows the improving the serviceability of the IBC, JBC, MBC, SBC. These are the dignitaries has been attended by. First phase we had carried the SCADA phase 1. In second phase we had carried at the 2019 SCADA phase 2. This is the date. Okay, thank you everyone for the presentation, for giving me opportunity for the presentation.
Thank you, Vinodji. Sorry for some of the glitches which happened from our
Yes,
side
yes.
and your side. Participants are requested to please post their questions if they have any. You can either put it in the chat box, or you can just unmute yourself, ask the question and introduce yourself and ask the question. Anyone who would like to ask any question? Okay, thank you, Vinodji. I guess there are no more questions. So
Oh,
thank you for
okay, thank you.
sharing your experience and making this presentation. Thanks a lot.
Thanks for giving me this opportunity. Sorry for the glitches. Actually,
No, it happens, it happens. As such, you are not accustomed for this particular thing, but we'll try once we are doing it next time.
okay. Thank you. Thank you very much.
Thank you. And for the participants, just a small announcement. This was the last faculty assisted presentation, which is over. After this, at 5 o'clock, there'll be two things which will be open. One is the feedback. All of you are mandatorily required to fill the feedback form. And secondly, there's a quiz. There are some multiple objective questions, 27 of them. You can attempt as per your convenience. Whenever you start the quiz, there'll be a time limit of 40 minutes for completing it. So you can start from today 5 in the evening to Monday 5 in the evening. So you have 3 days of time with you during the holidays as well as on Monday working day. As per your convenience, you can attempt it. You can make a maximum of 3 attempts and qualifying marks are 50%. So just see to it that you qualify. Only the people who qualify the examination as well as fill up the feedback form will be issued the certificate. And certificates will be issued on successful completion and you'll be receiving them on email. And a bunch of them, giving the summary of this particular program, will also be sharing with the WRD, Government of Punjab. With this, thank you, Vinodji. Thank you all the participants
Okay.
for patiently listening. Thanks a lot.
Thanks.
Thank you.